Welcome back, everyone. Today we'll be looking at the first store, the sensory register, that is part of the multi-store model. We'll be looking at three properties of the sensory register: coding, its capacity, and its duration. Now, for the capacity and duration, we'll be looking at the Sperling 1960 experiment, which is a fairly tricky experiment to understand, so make sure you take your time with this one. Before talking about the sensory register, we actually first have to talk about sensory information. Sensory information refers to information that comes in through your senses. What are your senses? Vision, hearing, touch, smell, sound, and so on. And all of this information gets stored in the sensory register. Therefore, its coding, which is the type of information stored, is all types. Okay? All types of sensory information, whether it's visual or auditory, it all gets stored in the sensory register. Okay? Some terminology. When we refer to visual information, we say iconic. And when we refer to acoustic information, we say echoic. And there are some other stores we don't need to know. But for example, haptic would be touch, and so on and so on. The sensory register is this truly fascinating piece of the memory system that has the job of filtering information so that only the relevant information is continued into the short-term memory. Now, if you think about it, there's so much information coming in from your senses that only a fraction of a percent actually gets passed on then to your short-term memory where actual thinking happens, right? So right now, as you sit there, you are probably not aware of all the information coming in, but we can direct your attention to it. For example, you probably weren't aware of how your feet are touching the ground. But if now that I'm saying it, you can probably feel how your feet are resting on the ground, right? So the information about that feeling were coming into your brain all the time. You just weren't aware of it because your attention wasn't focused on it. But your sensory register stores that information and makes it available to you in case you need it. And so it is this massive body, or massive, you could say almost like a tub, where it has a massive capacity where all the information can be stored and then accessed by you. Here's a little task for you. I'm going to show you a picture for 1 second, and I'd like you to observe what pieces of information from that image you can pick out. All right, here we go. 3, 2, 1, go. So, what do you remember seeing? You see this scene has a certain color gradient, so reddish. You might have remembered seeing red. You might have remembered seeing some kind of cliff or water or a man, a very tiny person standing here in the middle of the image, right? But you probably didn't see that there was mostly a blackish color here on the top left corner, or the cliff structure here on the bottom right, right? And so what this experiment shows you is that the sensory register, in combination with your ability to attend to it, filters out certain information that is relevant, right? It is relevant probably to know that there is a person standing in this image, and it's probably also relevant to understand the general structure of that there's some kind of cliff, or there's clouds, maybe the time of day, that this is in the evening or in the mornings, But the finer detail, that the structure on the stone or something like that, all of that information is not as relevant as the rest, and therefore filtered out, right? The point of this little exercise was to show you how amazing your sensory register actually is. It can take in so much information, and it automatically already picks out information from the entirety that is relevant to you. There's a little experiment we're going to discuss now, but if you're a teacher, you can actually do this experiment with your students in class by following us on Patreon, and you can run this experiment, and we have worksheets and explanations, and you can compare your student results with the results from the actual experiment. So in 1960, Sperling decided to investigate what the capacity and the duration of the sensory register actually is. So the procedure was to show the participants a grid, a 4x3 letter grid that he only showed for 50 milliseconds, which is about a 20th of a second. Okay. Right after showing that grid, he asked participants to recall or write down these 12 letters. So we're going to do a little bit of a trial run. I'm going to show you 2 of these grids, and I'd like you then to write down, after each time I show you the grid, you can write the letters down, and I'd like you to then see how many you get right. Here we go. All right, here are the answers. Now make sure to check which ones you got right. The position is not necessarily important. You just have to get the letters correct. So if you put C down here, that's fine. It's just you got to have C, okay? Now let's compare your score to the actual participants of this study from the 1960s. In the original experiment, participants were able to get about 5 to 6 items correctly. That's about 42%, which is about 5 to 6 items, okay? Now, why is that? Why weren't they able to get more? Why is that? Well, there are 2 explanations. Well, maybe the sensory register only has a maximum capacity of 5 to 6 items, right? More information is not stored, and that's why they were only able to write down 5 to 6 items. Well, that explanation makes a lot of sense to me, okay? But there's a second explanation we can come up with, which is this. Maybe the sensory register has a duration of less than 1 second, right? So by the time the participants wrote down the 6th item, the rest of the letters had already decayed from the store. So decayed meaning disappeared or being deleted, okay? So imagine this. Participants see the entire grid. 12 letters enter the sensory register, and they start writing them down. But by the time they reach the 6th item, the rest have already disappeared from the sensory register, okay? The difference between these 2 is to say this one says, well, we're only going to save the maximum capacity is 5 to 6 items. And this one says, actually, we haven't even reached the maximum capacity. Everything was in the sensory register. It's just that the duration of the sensory register is so short that it just takes too much time to write it down. By the time you reach the 5th or 6th item, the rest is gone. So which one's right? We're going to find out by doing a second version of this experiment. In this experiment, we're going to assign a tone to each of these rows. So in my example, we're going to have a bird for the first row, a cat for the second, and a lion for the third. Meaning, if I show you this grid and at the same time you hear a bird chirp, then it's telling you to remember or to write down only the letters from the first row. If you hear a cat, then you got to focus on the second row, okay? So what are our predictions for this experiment? Well, if explanation 1 is correct, and let's remind ourselves, explanation 1 said the capacity of the sensory register is 5 to 6 items. If this claim is true, then we should not be able to guess more than 2 correct, or to recall more than 2. Why 2? Because 2 is about 42%. It's slightly less than that, so it should be 1.8 or something like that. Okay, so we shouldn't be able to get more than 2. Why? Because assuming that we can store 5 to 6 items and we don't know which ones we're going to remember, say this one, this one, this one, this one, this one, and maybe this one, right? If they're randomly stored in memory, some of them and some of them not, then whatever row I pick, on average, I should have two of those 6 items in that row, okay? And so therefore, our average performance shouldn't exceed 42%, okay? Alternatively though, if explanation 2 is correct, which is that the duration is less than 1 second, then we can actually assume that we're going to have a higher performance than just 2 items. Why? Because if everything is stored in our sensory register, and then our attention is directed into a row, let's say we hear the cat, and our attention then gets focused onto this row, then we should be able to concentrate and write down these letters with a higher priority than others. And so therefore, if we perform better, by directing the attention into a particular row, we should be able to more quickly start writing down the relevant information and therefore achieve just more than just 42%. And that would show that actually explanation 2 is correct. So what are the results? Before we do that, I'd like you to try this yourself. So I'm going to show you 2 grids. If you hear a bird, focus on the first row. If you hear a cat, focus on the second. And if you hear a lion roaring, focus on the third row. I'm going to have 2 grids. After that, I'll show you the correct answers. Here we go. All right, now write down how many you got correct. 1 out of 4, right? So how many did you get out of 4 here, and how many did you get 4 out of here? If you got 1 right, that's 25%, 2 is 50%, 3 75, and 4 100%. So what do you think? How did the participants in the original study do? The results show that in the original study, participants got 3 items correct on average, and that's 75%. Now, how does this help us explain the sensory register? Let's look at conclusion 1. Conclusion 1 said that the capacity of the sensory register is 5 to 6 items. Okay, so that means that whenever I show a grid to you, you're going to remember 5 to 6 of these letters, but we don't know which ones. It's probably going to be random, so maybe you would remember this T and this H and this C, this M and this X, but not the rest. And so when I show you a particular row, right, the chance of you having remembered all of those 4 is very low, but on average, you should be getting about 2, right? Say, on average, you're going to get 2 in first row, 2 in the second, and 2 in the third. So if I direct your attention to one of those rows, you should be getting about 2 correct on average. But they got 3 correct, right? 1 additional 1, which means that more information must have been stored in the sensory register. So when I direct the attention of the participant into a particular row, they can neglect the information and not worry about having to write them down, and they can immediately go into the row that is relevant to them right now. And when they do that, they have more time to write down the letters, and that's why they reach 3 out of 4. So they didn't reach 4 out of 4, probably because they didn't have enough time to write things down, right? Maybe it took them too long to connect the sound to the correct row, and in that time the information was already decaying, right? So by the time they reached the 3rd letter, they had already forgotten the 4th letter. So that is very possible. In summary, the sensory register has an unlimited capacity. We know this because the Sperling experiment showed that all the information was stored in the sensory register, and we haven't actually found an upper limit in this experiment. Second of all, we know that the reason why participants weren't able to write down all the letters is because of the extremely short duration of less than 1 second that the sensory register has. And third, we know that it codes all types of information, visual, acoustic, and so on and so on. Next, we'll be looking at the short-term memory. Leave a like if you liked it, subscribe and hit the bell to get notified when we drop a new video. Download these and many more slides for free, and consider supporting us on Patreon and get access to detailed mind maps and past exam revision content. If you're a teacher, get free access to ZenTeach, an online quizzing tool with ready-to-go multiple choice quizzes and automated feedback. Make sure to use this invite code, which is, like all links, in the video description below.